Well, hello, calculus students and seekers of general truths. Let us work through an example here with finding a power series for a given function. So right off the bat, we can see and apply what we know about the sum of a geometric series just by rewriting this a little bit here. Instead of 1 over 1 plus x squared, we can think of this as 1 minus negative x squared. Okay, so if you go back to what we had before with the sum of a geometric series, then we can expand this, right? So this is like our common ratio here. Right? So this is our common ratio. Okay, so that means this expression can be expanded into a polynomial of 1. Right, negative x squared plus positive x squared times x squared, which is x to the 4th, minus negative x squared times negative x squared times negative x squared again, so x to the 6th and so on. Okay, and then in order to compact this down to write the general version of this, if you notice here, all we really have here are even powers, okay, or even exponents of x. The 1 here is, we can think of this as x to the 0th power, right? So x to the 0th, x squared, x to the 4th, x to the 6th, and then it is also alternating. Okay, so let's put this all together into a nice compact form using sigma notation. We're going to go from n equals 0 to infinity. And remember, the trick for us to get all of the even powers is to say x to the 2n, right? Because this guarantees that my result here will be even powered. And then finally, to get the terms to alternate, we can say this is going to be negative 1 to the nth. And so you can see that by using what we know about geometric series and just expanding that idea, extending that idea, we're able to take this function, perform a substitution, and then perform a substitution in the expanded polynomial to get a series. Now, once again, we have to talk and think through here, where does this series converge? Okay, so that's kind of a big question that we will return to in a minute. Where does this series actually converge? Does it converge anywhere? If we put in 3 for x, will it converge? If we put in 50 for x, will it converge? And so on. But I just want to start off with this idea here as we dive a little bit deeper and deeper into power series.